Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are still looking at graphs of polynomials. Just I want you to master this. It's really important. So this should be a short session where we go over a few problems. So let's look at the first two. In number 127, it says if A, B, and C are all positive real numbers, which graph could represent the sketch of the graph P of x is negative A times x plus B times x squared minus twice cx plus c squared? The first thing I notice is a negative sign outside, meaning my leading coefficient is negative because the x coefficient here is positive, the x squared coefficient is positive, so when I multiply them, I get positive. And there is a negative outside, so I can exclude 3 and 4. I know that the right-hand side is going down. Now, why didn't they give me this easier? Well, in fact, without even solving, this is easy because that's a perfect square. That's x minus c quantity squared, but you really don't even need to do that. Why? One of the factors is x plus b, meaning one root is at negative b. The graph crosses at negative b. I see this negative b, and this one doesn't, the b is positive on the right, meaning the factor would have been x minus b, so I know it's 1. However, I can still say it's negative a times x plus b times x minus c quantity squared. So it crosses at negative b, it bounces off at positive c. Crosses at negative b, bounces at positive c. So it's number 1. In fact, as I said, I didn't need even to show that this is a perfect square. On the right-hand side, which graph has the following characteristic? 3 real zeros, okay? And first of all, let's look at that. What does this say? It says as x approaches negative infinity, f of x is negative infinity. What are these? Yeah, that's what we call the end behavior. When x goes to, you go to the left until you go to negative infinity, the graph itself is going down on the left. And as it approaches positive infinity, you get positive infinity, meaning the graph is going up on the right, down on the left. Well, there is only one, and that's it. This one goes up and down. This is down and up. This is both up or both down. So I know it has to be number 3. Notice it says it has 3 real zeros. That's 1, that's 2, that's 3. Very easy. I told you that would be an easy session, but few minor things that I don't want you to lose track of. Which graph shows a 4th degree polynomial? Meaning my graph has to make 3 turns, 4th degree. Goes, for example, up, then down, then up. And I know because it's 4, 4 is an even number, then the right and the left match. I can just ignore number 3 because they don't match. It's one of these 3. But I know this is quadratic. It's only making 1 turn, right? So it couldn't be 3 or 4. But it has exactly 2 imaginary roots. Which one has imaginary roots to begin with? Both of them are 4th root. This one has 4 zeros, and all of them are real. And of course, this only has 2, but when it goes up, it doesn't reach the x-axis and cross it. No, it turns below it. And that's why I have 2 imaginary roots. When you solve, you get only 2 positive, I'm sorry, not positive, 2 real roots. So it is number 1. Okay, you have to read the whole thing to make up your mind. A 4th degree polynomial, yeah, all of them are 4th degree. they have three turns, up, down, up, and then, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. But now they tell you it has zeros at negative 5, 3i, and negative I. I and negative I, meaning two of them, it will cross only twice, and the other two are imaginary. This one crosses four times. So it couldn't be that, but crosses four times. It couldn't be that. Okay? So it's one of these two. It tells me one of the zeros is at negative 5. That's negative 5. That's negative 5. And those are negative 3. So it couldn't be this. It must be number 2. It has two imaginary. It passes at negative 5 and positive 3. So it's number 2. Then we go to the last page. Which graph could represent a fourth degree, all of them are 4 degree, polynomial function with a positive leading coefficient of 2, meaning left and right must be going up. I can ignore these two. It has two real zeros and two imaginary zeros. Then it's number 1. Two real and two imaginary. This has 4 real. Number 2. Let's move to the right-hand side. The graph of the function f of x is shown below. In which interval is f of x always positive? Positive meaning above the x-axis. Notice some students confuse between increasing and positive. This graph is increasing from negative infinity up to this point, or from this point to that to infinity. That's increasing. Going from left to right, you move up. But they didn't ask you increase it. They said positive. It's positive between this point and that point, so between negative 10 and 0, and it's positive above positive 10. So which one? Negative 2 and 4. Well, this is negative 2 and this is 4. In fact, it's decreasing. No. 0 and 10? 0 and 10. No, it was decreasing first and then increased. Well, negative 12 and negative 5. Negative 12 and negative 5. It's increasing, but it's not positive. That's the trick. Do you see that? It's negative 10 and 0 is the correct answer. Here is negative 10. When it was 0, it stayed above 0 until it reaches 0. So during that interval, it was positive, meaning it was above the x-axis. Do you see that negative 12 and negative 5, it was increasing, not positive. And for some reason, I see students confusing these two terms, increasing and positive or decreasing and negative. You have to understand increasing, meaning as I come from left to right, I see that my graph is going up. That's increasing. Increasing, but became positive here. It's both increasing and positive between 0 and negative 5. I'm sorry, between negative 10 and negative 5. And then it's just positive, but decreasing. So this part from here to here is increasing, decreasing, increasing. But positive, negative, negative, positive. Don't confuse the two terms. 133. Consider the end behavior describing those. As x approaches negative infinity, meaning when I'm on the left-hand side, the graph is going up. When I move to the right, it's going down. So that's the degree is odd. Notice these, both of them are going down. So it couldn't be 4. This, the right-hand side, where is there? Oh, there is 1. 1 and 3 are written. Okay. So on the right-hand side, it's going up and the left-hand side is going down. So this is wrong, this is wrong. It's one of these two. X to the 4, what does it say? Even degree, meaning they have to match. Oh, they are not matching. So it must be this. Well, look at it. First of all, there is a negative, meaning the right-hand side is going down. The degree is odd, meaning they are opposite. If this is going down, this is going up, so it is number three. And that concludes this short session. That at least now I think you have all the ingredients not to ever get wrong on these types of problems. You know everything from leading coefficient to degree to imaginary and real to increasing, decreasing versus positive and negative, and so on and so forth. I hope that concludes this part of the course with no trouble whatsoever for you. Again, feel free to leave me a comment if there is anything unclear or you want more problems. Otherwise, I wish you all the best. Have a great day, and I'll see you soon. Bye.